We've talked about making circuits, digital logic out of gates, and we have done three basic gates. The three basic gates we have done have been looking at the AND gate, the OR gate, and the NOT gate. But we have saw that we have other gates that are available. One that we have really looked at is an XOR gate. Now, when we actually come and we're looking at creating a digital circuit, and this digital circuit, we want to make it in an IC chip, where the IC chip is, think of anything electronic you have open up. You usually see some like black squares. Those black squares are an integrated circuit. It's an IC chip. Maybe you build a desktop yourself. You've seen the processors. Okay, you got some idea of an integrated circuit there. The technology we use to make an IC is called CMOS. And CMOS stands for complementary MOSFETs. Complementary means that we have items that are identical. And one unique item about the MOSFETs is we only can create new types of gates called NAND gate and a NOR gate. And everything we built has to come off of these different types of gates. So a NAND gate, the symbol is it's an AND gate with a little circle at the end. Now this little circle at the end means that we NOT the result. So in actuality, this NAND gate is the same as if I had an AND gate followed with a NOT gate that follows right after it. Okay, so let's look at a truth table that we have for this NAND gate. Well, what's an AND? We know how AND works. Both conditions have to be true. So the NOTing of it happens at the end. When both conditions are true, we'll get a 0 output. Every other condition will give us a 1. Well, the beauty of the NAND gate is the NAND gate is called a universal gate. And a universal gate means we can make all the basic gates from it. So there'll be a way that I can use a NAND to make a NOT. A way I can use an AND to make OR to make NAND. So there's going to be methods of how we can actually build them. Now, the method we're going to do to build them is we have to kind of figure out how do I build each of these. So let's look at a NOT gate. So let's do a NOT from a NAND gate. All right, so how we're going to go about building this is what I want at the end. And what I want at the end is, given a value of A input, I want A bar. All right, so let's do this NAND, and let's see how it's created. All right, so we have, let me change letters here. So let's have this one be an X and an X bar, and then we have AB. All right, so let's draw AB out on this truth table. And in this truth table, I have this NAND. So I have a NAND gate. The output of this NAND gate was 3 ones and a 0. And what I'm trying to create is an X NOT. And I want this X NOT to be able to be created. So for X NOT, we need a 0 output. We need a 1 output. And how are these created is a 1 has to produce a 0, and then a 0 has to produce a 1. Well, how can we get that from this NAND gate? Well, if we look at this, there's only one way I can produce a 0. How is it that I produce this 0? Is this 0 is produced by having both inputs be a 1. And both inputs be a 1, well, how is that actually created? Is I take this NAND gate and I say, I have two inputs that are coming in. Let me tie them both together into 1. So let me just call this A, because here I have A and B, but B is really an A. So I got two A's going through. Well, 1 and 1, it will give me 1. And look at this. The other condition is if I connect them both together, 0, 0, it's going to give me a 1. So I end up getting that same output as a NOT gate. So what do we say? We can say to create a NOT gate, you take an AND gate and you tie both inputs together. So we already have one way that we can make a NOT. All right, so we take that, and now I want to say, how do I make a NAND gate? An AND out of NAND. Well, if I start off with NAND, and I have AB, the output is AB bar. Well, I want to take away the bar. The AND here needs to remove the NOT. Well, how can I remove the NOT? Well, if I put another NOT after it, well, look at this. I get just AB. Well, how does that get created from? So how to create with NAND gates? Well, it's simple. It's just a NAND that has two inputs, A and B, and then the output, we already know how to make a NOT gate. Both inputs drive another NAND. All right, one gate left. How do we do an OR gate? So how are we going to do this OR gate? All right, so let's set up items that we know about. Items that we know about is I have AB. AB, I know I got a B with a bar over it. I know what that output is. And at some point, I want to create A or B. So I'm looking for a 0, 1, 1, a 0. Okay, so we need to try to figure out how can I generate this. Well, let's look at this AND gate. And I know it's B with a bar over it. Well, let's take this item right here and let's apply De Morgan's law to it. So if I have an A and a B bar, I'm going to reconvert this, and that comes out to be A bar or B bar. Okay, so this is what I want at the end is A or B, and really the NAND is an A bar or a B bar. So how can I produce this is what I really want coming out of this is if I had this NAND gate with NOTs coming in. Okay, so I have AB, input is A bar, B bar. The output is A bar and it with B bar with a bar over it. Converting it into De Morgan's gives me, I have A bar bar or B bar bar. Take off those extra bars, what's A or B. Bingo, that's what it is that we want it. So how do I produce this? Is an OR gate is going to be our starting NAND with the NOT in front of it. And that would be what an OR gate is. All right, so let's review. NAND, how do I make an AND gate, an OR gate, and a NOT gate? The NOT, both inputs are tied together. The OR, we NOT the inputs coming in. And then the AND, I take the regular NAND, and then I'm going to NOT it at the output. And that's how we produce all three basic gates. Now, NANDs aren't the only gates that we can have, that the CMOS can create. We also have a NOR gate. And again, this NOR gate is a universal gate. All right, so what is a NOR gate? A NOR gate is, I have an OR with a circle in front of it. It produces, I have A, B coming in. It gives me A or B with a NOT over it. All right, so let's look at the truth table for this. A, B, 0, 0, 0, 1, 1, 0, 1, 1. Well, I'm going to take the OR. So that's 0, 1, 1, 1. And I want to do the opposite over it. So that's 1, 0, 0, 0. All right, so this is right here at the last piece. That's the NOR output. All right, so I got to build the gates out of here. First off, let's do the NOT. So a NOT from a NOR. All right, we have this truth table. Let's look at it again, because we're going to follow the same process of how we create stuff out of a NOT. So I want to produce X bar. I need to have that to do this NOT gate. I have X, I get X bar, a 0 gets a 1 gets a 0. Again, look at this. There's only one way to produce a 1, and that is if both inputs are the same. So if we have both inputs the same, it would get a 1. Similarly, if both inputs are 1s, I'm going to produce the 0. So the NOT gate looks the exact same as NAND. Take the gate, and both inputs are tied together. So here, if I have an A, I would get an A bar on the output. So we have one gate, and that's going to lead us to build the other types of gates. So how do I do an OR gate from a NOR? All right, so I have my NOR. I get out A plus B with a bar over it. We need to remove the NOT. Well, how do I remove the NOT? I send it through another NOT. Now we get A plus B. So that's easy for us to make. Take the NOR, and then I'm going to add in the equivalent of a NOR, of a NOT using a NOR. So that both inputs get tied together. All right, the last thing we have is how do I make a NAND gate from a NOR gate? All right, it's going to be very simple. So I have A and B producing A or B bar. Same thing we did on the NAND gate. Let's look at De Morgan's. That ends up being that I have A bar ended with B bar. I'm getting very close. I just need to NOT the inputs coming in. So what I'm going to need to do is take that NOR. The input into that NOR is the NOT of A. So I get A. I'm sending in A bar. I get B. I'm getting B bar. Well, here the output is A bar or B bar with a bar over it. De Morgan's is showing that as being A bar bar ended with B bar bar, which is AB. And that's how I built that AND gate. So quick review. NORs. How do I make a NOT? Take that NOR, tie both inputs together. How do I make an OR? Take the NOR gate we have and put a NOT at the end of it. And how do I do an AND? And your inputs into the NOR, NOT them. And that's how we built these 3 gates. Next time, we're going to look at converting a circuit we have, like an SOP circuit, into these types of operations.